All right, everybody, and welcome to the October meeting of the Homebrew Robotics Club. We'll start this off with robot news. Do we have any robot news out there to report?
I saw something, Camp.
We got a report from Roscon. Fergs, did you go to Roscon?
I did. I'm still getting over a cold that I caught on the way home or towards the end of the week, but yes.
That's a good thing the meeting's virtual. What was the biggest and best thing at Roscon?
I didn't actually go to many talks, so my whole thing is walking around chatting with people for the most part. So I think the talks will be, videos will be up in like a week or two probably. So, yep.
I think there were like 40. Go ahead.
No, I was just gonna say I did post like a little recap of thoughts and themes on my blog. So that's on robotandchisel.com. I put that up yesterday.
Put a link to your blog in the chat.
Yeah, I'll put a link to that post. It'll just take me a moment to find.
How about Maker Faire? I don't see Marco there. Maybe he's on his way.
One thing I saw was Disney has their little robots up and going. These little BD something or other. They're coming.
You got that video?
Do I have the video? I was going to queue it up. Give me a minute.
Like BB-8 from the movies?
No. Those no, a different one. These little I don't know, bird-like
Walkers, chicken
This
walkers.
one's BD1 with legs, basically.
Thank you.
Pretty cool.
It is pretty cool. I'm trying to queue it up here.
They 3D printed most of the parts, carbon fiber. Pretty cool. Are you cold there, Thomas?
Okay, I'm ready for that video. You ready for the video?
Share your screen, dude.
I just grabbed the first one off the top. I'm hoping it's a good video.
Share your screen.
I'm doing it. Give me a second. Oh, can you let Jim in the door?
Let him in and he's in.
All right, we good?
I see your screen. Not seeing the video. Not seeing the video.
Did I share the wrong screen? I think I shared the wrong screen.
Share the right screen.
I would like for you to move up just a little bit, okay? Let's go. They're a little shy.
Not a simulation.
Say hi, Blue Dot. He's waving hi. He said hello. All right, let's keep it moving. Orange one, how you feeling this morning? Dan? No. We'll fix it. What is it over? This way, Blue Dot, this way.
Very cool. Thank you, Thomas.
Yeah.
What else? Any other robot news out there? Did Marco show up? Try to get a report from Maker Faire. Anybody go to Maker Faire?
I went to the Orange County Maker Faire.
So did
How
I.
was it?
So did I. Good.
It was small. Northern California stole all the people and the exhibits.
Yeah.
It was fun. I had fun time.
I went to the Bay Area, went up there, and I mean, Dee took so many pictures, it's hard to compete with that, but I took some pictures. What is
Dee Dee's one of my favorite people.
yeah, I saw that. So let's see. Here we go. Can you see that?
Yes.
So yeah, that
It's all that Burning Man art.
very interesting location on an old naval base, and their dark room was really pretty good this year. This is brighter than it. Oh, here's. Is that video coming out? Let me let me optimize for sound. So yeah, this it's some pretty neat, very psychedelic plays as usual.
A cuttlefish, isn't it?
Yeah, it's a giant cuttlefish. At the time I looked at it, I thought squid, but then yeah, and I'm a big fan of cuttlefish, so I don't know why I thought that, but it kind of cuttlefish and squid are in the similar family, and then you got the jellies above, and then this was cool. This they called it kind of a forest. I forget the exact name. But you could go under these, well, at least small people could go under and chill on the rug. This was cool. I don't know. I just like mechanical things. I guess the audio isn't very important there, but all these gears, I'm like, that's a pretty good bunch of servo motors or something. Here's another light display. And then outdoors, yeah, there's your typical Burning Man stuff, all sorts of steampunk and weird contraptions, especially
I know
like,
those people.
yeah, you know,
I know those people.
you know those people.
Yeah, that's the Never Was Land or something.
Yeah, Obtainium Works. There's this one with the trash cans. I kept thinking there was a lot of robots here that I'm like, God, Camp could have made that, you know, because like a trash can rolling around or a skeleton
Because
roaming.
it was built so poorly. Is that why you say that, Joe?
No, it's got the creative flair of your of what
Yeah, you're not gonna talk your way out of that.
no. This one was, yeah, no, yeah, it just they have these skeletons and things that remind me of yours, but
Yeah, that's very cool looking.
This is a cool guy. I mean, I just learned about this robot and thing and saw the video, and it this puppet sings and plays the piano, and the piano opens and there's a disco ball, and it drives around on its own, and you can't even find the guy controlling it. I don't know where he is. The steam engine was there. That's cool. I got a printed coaster from that printing press on the right. It's pretty cool stuff. Three color print. In the robotics area, where everything that we know is happening. This was one of the, person can go in there. This Dalek was remote control, and
I like the plunger. That's
Yeah, the
authentic.
plunger, it's perfect. And the guy had the complete with the garbled voice, you know, it was funny. Lots of good exhibits. This is a mechanical spirograph type thing, not really a spirograph, but dating from the 1920s. Oh, there it is, the Wonder Graph. It goes back to the I love things that are so old, but they're really kind of cool. So yeah, there's these slides are up. Oh, and here you recognize this is
Marco's.
Marco's. I was asking him, how did you get that? You know, he's like machined in Germany, because it was more expensive in the US, so you could get it in Germany and shipped for the less, I think. Yeah, these are all the, I guess,
Table box.
yeah, I guess these are Marco's and maybe some other people's too. I'm not sure. Yeah, but I just took the pictures of all the. This is Marco has some. I didn't realize he has two soppies. I mean, building one is a lot of work. He built two.
Marco's a robo star.
Yeah, I look up to you know our mentors like him.
R2, where aren't you?
Yeah, so this was the BB-8 Builders Club and the Droid Builders Club. The BB-8s are so cool with their floating head. Did I take a video? I don't know. Maybe later. Some of the artwork, the metal. I don't know how they make those metal parts. And then here it is, the greatest show and tell. We should use this slide when we do show and tells. They had this giant.
Ours are the sometimes they're the not so great show and tell, but go ahead.
Yeah. Easily amused. Remember, this was a giant orrery, unbelievable, you know, and it was running the earth, you know, the earth. I mean, I don't know how long you'd have to be there to see like Pluto go or Uranus go around. It went probably once in the whole 2 weeks. Giant room. It's just more artwork. This thing was kind of fun. It was like they did a countdown of the I think the John Glenn first orbital mission or whatever the launch. So they play this really loud on the speakers, the whole countdown from like 2 minutes, and then you know, that realistic looking nose or what do you call it, rocket cone emits a bunch
nozzle.
of rocket nozzle emits a bunch of you know, dry ice and whatever when they take off. Yeah, the night, these are some cool. This one rolls around, and this one rolls around, a very steampunk looking thing. Oh, and you might recognize Christoph.
That's Christoph's Mona.
Mona. Yeah, Mona.
Mona got Editor's Choice Award.
Yeah, I saw you saw that. I didn't see any. I didn't really look at the awards except one or two. They kind of gave them out late, but yeah, this is it's amazing to see it in person, and it looks like it, you know, multiple years of intricate detail and design. It's unbelievable.
Christoph's a smart guy.
Yeah, not just smart, but very patient.
His robots don't look like mine.
Yeah, I mean, this is like, I mean, he's starting a company now and he's hiring people. So, and then you might recognize Dan. This is
Dan.
He's trying to sell
Watson. Or Karen. I think that's Karen now.
Karen? Oh,
yeah.
But that's Dan.
And then she needs a head.
Yeah. Oh, the head.
Needs a head.
Yeah, so there were some talks that one was about this new AVR and MCU family, and microchip was there, and this sounded exciting with this new chip family, new features, and they have a board. They have one board out, I guess, already, but it's the future of Arduino. Oh, and this was really cool. The hand from Thing. I talked to this guy a bit. It was fun to and here it is moving. Yeah, there's no need for audio. What's that?
Uncanny.
Yeah, and it's a pentapod, but and it's just remote control. and it doesn't appear in the show. It's just, it was made for this New York video. Just Google thing in New York, or go to YouTube and say thing in New York, and you'll see this really funny video of him scaring people. Oh, here's a video of BB-8. BB-8 is just so cool, but you know, it's more of in the cinematic robot world, which I've never really gotten into. It's a lot of work, and it's pretty much all remote control. And then there's of course, the fire stuff. These were the flaming lotus girls or something. Is that what they are?
Yeah.
And the little children could press these buttons that make that thing flare up and pull the propane.
This is hardcore Burning Man stuff here.
Yeah, it's funny how there's a crossover with Burning Man and you know, and Maker Faire. It's always been like that. Here's the presentation he did, and you can see that the 3 different there's 2 different hands they built. The one for the upright you know, shots, or not shots, but whatever, demos, and then the crawling one. And then they have a crawling one with no skin on it there as well, which has these little spikes at the bottom, so it can. Oh, and here's yeah, this is Christoph's promotional picture here. So I definitely want to learn more about it. And yeah, and his info there. More metalwork. And then wacky stuff like a guy in a tea kettle, in a Aladdin's lamp, talking to small children who are making wishes to fly.
Isn't that Major Disaster?
Oh, is that what the name is? His name?
That's what that guy's name is, I believe.
Oh, yeah, you know better than me. All right, that's all my pictures I had.
Thank you very much, Jim. That's the report from Maker Faire Bay Area.
I got one more thing, Camp.
But
Yeah, Arduino has come out with a GIGA display shield. It's pretty impressive. You want to see it?
shoot,
You didn't go camp, right? You didn't fly
that's
out.
true. I enjoyed it vicariously.
Because yeah, I think Walter thought you had flown out, but those were all Dee Dee's pictures.
All right, this is 30 seconds, guys. Yeah, it just kind of plugs in the back.
They put a price on it?
It was under 100. I don't remember.
Okay, very nice. Hey, we need to move along because I got a presentation here. Dillo, I see you came in a little late. You want to give us a Roscon report? Hello,
Can you
Dillo.
hear me?
We can hear you.
Okay. Hi, yeah. Roscon. I went. I got the t-shirt. This is not the Roscon t-shirt. This is a Foxglove. Anyways, it was in New Orleans. This is the first. I wouldn't want. Well, it's kind of late in the year, so it's not the first one since the pandemic, but it is the first one in North America and the first like general one. It was in New Orleans. It was supposed to be there in 2020. Of course, that didn't happen. It happened online in 2021. Tried again in 2022. You know, so so it was in New Orleans. The day before was the first Move It Con. So Move It by Picnic Robotics, which is about software kind of like Gazebo, somewhere between like Gazebo and Arviz, but for ARMs. It's a motion planning, kinematic solver. Actually, it's like a plugin for kinematics, for interest kinematics for ARMs. So they had their own con. I went to that. That was cool. They showed off Move It Studio. Let me see if I can get a video up here. Which is their, so there's Move It, which is open source. The original version started at Willow. And then there's Move It Studio, which is kind of like their commercial package, their commercial version. Okay, yeah, I don't have the video uploaded. Maybe you come back to it later.
Drop it in the chat when you drop it.
Yeah, I'll dump it in the chat when I get to it, my Google Drive. So Move It Studio is kind of like it's like the gazebo, it's like Gazebo for ARMs, and it's kind of a lot more full featured. It features behavior trees. So it's compatible with ROS 2. In fact, the current version is more focused on ROS 2. One thing that they're doing in Move It Studio is, or sorry, one thing that they're doing in Move It is a Python API that is independent of ROS. Right now in Move It, if you want to do something with your ARM, and you actually get around to the display of the planning solution, or if you are controlling a real ARM, all the calls to the motion and the planning calls, they go through the ROS libraries. So even if you're not actually using ROS on your ARM, you have to have ROS installed on the system, because using the ROS IK solver, it's using the it's using the joint controller and the motion controller. So they're working on a Python library that kind of splits that out, so that you probably will have ROS. People probably will, kind of like when you're using Gazebo. But you don't have to if you don't want to, and so this makes it independent.
So Move It's like separate from ROS now, even.
Yeah, it's getting to be separate. This makes it faster, and it also means that there's more Python support for it. Which
all right, we need to move ahead. We got a presentation.
Okay, so Roscon, probably the most. Let's see here. Yeah, I'll put up links to images and stuff. There was at the simulation. There was a whole day on simulation on Gazebo and Isaac Sim and other simulators. And one of the cool things that I liked there was a guy showing a Mecanum OmniWheel simulation. And he showed that if you tried to emulate the actual roller, if you had like your model of the roller, and that was also your collision mesh, that the robot kind of bumped along on the surface and it didn't really move perfectly sideways. So if you're actually doing like the kind of like the side traveling strafing, yeah, I guess people call it strafing action, it would kind of bump along. But if you simulated the collision mesh as a bunch of spheres,
yeah,
then simulator has, like, the physics simulator has an idea of a perfect sphere.
All right, we need to move along.
Yeah, I'm here instead of down there because
Yeah.
I also brought back a cold. So
Sounds like it was going around. We need to move along because we've got a big presentation coming up. We could spend hours talking about gazebos, so I'm going to cut it right there. Let's move along. Let's keep it brief. Club news. We've got a business meeting next week. That's November 1st. Business of the Homebrew Robotics Club, mostly about presentations. We got a big meeting.
Camp, can you hear me?
Yes.
I've got club news too when you're ready.
Oh, okay. Go ahead, Dan.
Okay, let me see if I can get on camera.
I see Marco there now.
Okay, so we have about 27 people online. We have 12 people here in orbit who kindly lent us their space. In a second, Chris from In Orbit is going to come out and just say a few words about what they do. What I wanted to talk about is officers and elections. We have 11 general meetings a year. We don't have a meeting in December. So our next and last meeting for the year is November 29th, and that's when we do our general elections. We have 5 elected officers. Camp is the president. I'm the secretary and treasurer. We have webmaster is Al Margolis. Sergeant at Arms, who's been running the audio and video for this, is Ralph Phipps. And the most important, who I'm blanking out of his name, is the guy who gets us all of our programs and all of our speakers. Help me out here. Stephen, yeah, Stephen Williams. So anyway, sorry about that. So we have 5 officers, but I hear rumors that we might have a couple of officers that are retiring. We're looking for new blood. We're looking for people who can put energy into the club, up our game, bring in new ideas. The club is all run by volunteers. So think about it. Think about whether you want to be an officer in the Homebrew Robotics Club and help contribute your special talents to the club. We have these 5 different officer titles, but everything crosses over. Everybody's involved in making decisions and keeping the club moving forward. So elections are November 29th at our next general meeting, which is the last one of the year. And that's when we'll decide who are the officers for the coming year. That's all I wanted to talk about. Also, we'll have membership opening up next November 29th. We'll open up membership for the 2024 year. Stay tuned for that. I'll put more information up on the forums. At this point, I want to bring Chris out here to talk about In Orbit. So volunteer, I guess you can volunteer to Camp or myself if you're interested in one of the officer positions, and we'll figure out how to put together the ballot. Thanks. Chris, you're on.
All right, hey everybody. My name is Chris. This is the In Orbit Robot Space. Just wanted to welcome everyone here. Short little blurb about In Orbit. We are a software platform. We work with autonomous mobile robots in a variety of industries, primarily in retail logistics, but also everything from hotels, hospitals, construction sites, farms, pretty much industry platform robot agnostic. So if you ever have any need for any kind of control of your autonomous fleets, look us up. This space here in downtown Mountain View, the robot space, for us, it's basically like a permanent trade show exhibit. Since we're just a little startup and hauling big robots across country all the time is pretty cost prohibitive. So that's a permanent home base for us. But it's also open to the public. So we, to the public, everybody can come in and learn more about the industry, and we host a lot of events here, such as this tonight. We have done everything from classes from middle school to COU grad level classes to workshops, panels, all sorts of things. So if you guys ever have any, particular thing you want to host here, we're always willing and happy to open this place up as a community space, such as tonight. And yeah, that's kind of special little blurb. Our CEO was on the August speaker, so if you guys were here for that call, probably should be a little bit more of what we do, and then some of that quick down. But you guys are always welcome to drop in. We're open Monday to Friday.
Florian Pesconi's a righteous dude.
Yep. So yeah, we're here Monday to Friday, 12 to 6, barring whenever we close for various demos, which is fairly yeah.
Thanks for a big round of applause and thank you to In Orbit.
Thank you very much, Chris.
Yep,
Um,
back to your regularly scheduled business.
Yeah, one more thing is I want to add to the officers is that presentations is everyone's job, okay? So you're out and about and you see something robotic, or you meet somebody in the industry or has something really cool, you know, ask them if they would do a presentation, and don't commit to it, but get back to Stephen Williams, our program chairperson, and we'll schedule them. So presentations are everyone's job. We're going to move this thing right along. And without any further ado, let's go ahead and get into our why we all came here this evening, our presentation live from New York, Build Robots with Viam by Hazal Mestci. Hazel is a developer advocate at Viam. Her day-to-day involves building fun robots and smart machines, coding, wiring, hardware, and leading initiatives to engage, educate, and inspire developers through compelling content. This evening, we will learn how to create an autonomous drink delivery robot designed with ultrasonic sensors and cameras. Tipsy is equipped to detect the presence of obstacles and people in its surrounding area while avoiding obstacles with the ultrasonic sensor measurements. It identifies people using a machine learning model and object detection and move towards them with ease. Tipsy allows people to grab a drink without ever having to leave their spot by bringing a bucket of ice cold drinks within arm's reach. So without any further ado, I bring Hazal Mestci. Thank you very much, Hazel.
Hello everyone. I will just share my screen because I created a presentation. So thank you for the introduction to Camp. I'm gonna present a project that I built with my team at Viam. It's called Tipsy, the autonomous beer carrying robot. I love beer and I love robots, so makes sense. This is how it looks like when it's actually in a production mode. So we used it at our GA party. It has acrylic panels in the sides, and then it has a camera that detects the people, and it has ultrasonic sensors all around in the front, so that it doesn't hit anything. My personal background, so I did design and technology undergrad, and I'm currently doing a computer science master's. My first job was a teaching job, mostly for coding and hardware and electronics, and then after school. And then I started at a makerspace as a creative technologist. And then I was doing a lot of 3D printing, laser cutting, digital fabrication, and building curriculum for kids. Now I'm at Viam and I'm building robots and documenting them. And this is Tipsy. So just the general breakdown of what it is: it uses a Raspberry Pi for compute and GPIO motors to move. It uses ultrasonic sensors. It uses a webcam and a commonly available ML model to detect the people, but you can also train your own using VM. So if you want it to only detect you and come to you, or if you want it to detect your neighbor and go over there, you can also train your own. It uses Python SDK code to control the robot, so like intelligently making move autonomously, and it uses the VM software to bring all of these together. These are the steps that I used to build it. It's also going to be the agenda for my talk. The first one is building your machine, so assembling the hardware and wiring the components. The second one is configuring the components in the VM app. Third one is to test all of those components. Fourth one is adding services for smart capabilities, which is going to be vision service and ML model, and then coding to control the machine. So the first step is this. The shopping list that I had for the robot was a Raspberry Pi with a micro SD card. I had assembled SCUTTLE robot. Maybe some of you may know them. They're based in Texas. They do mobile robots. Battery, DC to DC converter, T-slotted framing, which is supposed to be for the sides, and then under the box, ultrasonic sensors, camera, and then the box to hold the drink. This is the wiring diagram. And these are some process photos. Over here, I was just testing 3 ultrasonics, and then on the side, I was testing the rails and the beer carrying capabilities. The second step is connecting and configuring your machine. So this is how I started like learning robotics with VM. I knew a little bit of hardware before, but then I didn't know how to control these motors. I didn't know how to see the camera stream. And I started using VM, and I realized that it's very easy to configure these components using the software. The components we are going to configure are the board, the motors, camera, base, and sensors. And I have a video actually connecting to my robot and actually configuring all of these components. I didn't want to make it faster because I wanted you to see how fast it is to actually connect to my robot. Here, basically, I'm SSHing into my Raspberry Pi, and I'm downloading the VM app configuration to that computer. And then I'm downloading and installing VM server into that computer, which is the Raspberry Pi, the brain of the Tipsy robot. And as you can see, it downloaded literally like in less than a minute. It's 30 seconds. And if I refresh my page and wait like a minute, we will see that it is connected to the robot. And after that, we will be able to go to the configuration and basically step by step add all of the components that we are going to use. I had to refresh it a few times, but it's going to connect. As you can see, there are different architectures that you can try. So if you're using a Mac and you want to run the VM server on your Mac, you can also use that. If you have a Linux computer, you can use that like instead of the Raspberry Pi. So now we are connected. And in the next slide, we can see that if I go to my configuration, I can just start adding all of my components. The first component that I'm adding is the Pi. I just named it local, but it can be anything. Then I'm gonna start creating my motors. I use 2 GPIO motors, encoder motors. You can use any type of motor. We support a bunch of built-in boards and motors and cameras. In the attributes, the only stuff that I have to add is where on the Raspberry Pi my motor is wired to. So I use the 15 GPIO and 16 GPIO on the board, and that's it. I just have to say that the motor is connected to the Pi. So unless the Pi is initialized and Pi is working, then the motor is not gonna work. But outside of that, it just tells the VM software that this is where it's connected to. For the left motor,
are you just configuring a differential drive robot, right?
Yeah, it's a wheeled motor, like wheeled robot with 2 motors. And after that, this is where the 2 motors get connected. I'm just creating a base, naming it Tipsy base, and I'm telling the software where are my motors and the wheel circumference. So it's important to actually
bear with me. This VM framework is where you're putting this information in, and then it's going to generate the Python code?
Yeah, you're going to see it very soon. It's also going to allow me to test all of the separate components. So I'm basically selecting local right motor and left motor since the base depends on all of them. And I'm going to add some of the other components that I have. One is the camera. It's just like a simple webcam camera. As you can see, there are different cameras available for you to use if you have different models. Again, it's going to depend on the board, because if the board is not working, the camera is not going to work. And I have 2 ultrasonic sensors. So in this case, because my robot is not that tall, 1 ultrasonic in the bottom and one ultrasonic on the top was enough for me to avoid the obstacles. If you have a taller robot, you can have bunch of ultrasonic sensors on the rail. You can maybe have a depth camera if you want to use depth camera for obstacle avoidance. But for this use case, just 2 of them was enough when I was doing the testing. So
did you specify a location of the ultrasonic here, or are you just telling it that you've got ultrasonic sensors?
So I'm just specifying the trigger pin and the echo pin, which is very similar to how we configure the motors. I'm just telling where on the wiring diagram, like where on the Pi it is connected to. And as you know, like ultrasonics only have a power, ground, and then 2 pins. So these are the 2 pins that it is connected to. So now in literally 3 minutes, we configured our entire robot. These are all the components we have, and everything is at VM. So the third thing we are gonna do, and like I did as I was building it, is actually testing the machine. Each configured component can be tested individually. I have a video for this too. So if we go to control panel, as you can see, all of the things that we configured, I can go back a little bit, is right here. So we have the base, we have the motor, both of them, we have the board, and we have the camera. So if you go to the base, you can turn your camera on. That's where my desk is. You can enable your keyboard. You can start moving your motors. So now you have a robot, that's me, earlier today. And you can test your motors specifically, like if you want to make it go backwards, maybe you're testing your encoders, you can test them separately. The camera, you can test it separately. You can export a screenshot if you want to, and then you can get readings from the sensors. So that's great. And now, sure, we have an autonomous, like we have a robot, but it's not autonomous. It's not actually using any code. So how can you make it smarter by using, like adding some services and then start coding it? On the right in the image, you can see all the services VM supports and like provides. We have data management, we have motion, we have frame system, navigation, SLAM, a bunch of other ones. But the ones that I'm going to use for this project is ML model and vision service. So let's see how to create those services. So the same way, like this was components, in the next tab, you have services. It's literally the same way that you can add a component, you can add a service. Currently, we are adding an ML model, and I'm going to show you how to deploy a model on the robot. So over here, I already used the person detection model, like an ML model before on this project. But I'm going to click on add new model so that you can see how fast it is to add your ML model over there. You basically have to find a TF-Lite library, and you have to find a labels text. These are all the things that this ML model can detect. So it can detect a person, it can detect a bicycle, it can detect a car. It's a very general one that I'm using. Because I'm only detecting a person, it's going to serve me the best. But this is what the labels text include. You say open and you click upload, like you give it a name and then you give it a model type, which is going to be object detection. And you click upload model and it takes literally 2 seconds for it to get uploaded. Now, if I go back and save my configuration and refresh my page, you will be able to see that model is deployed on the robot. Similarly, if you train your own model, you can do the same thing and add that model on the robot. And now we have to create a vision service. A vision service will allow us to use the camera intelligently to interpret the world around us. Without the camera, like seeing the vision, we wouldn't have anything to detect. So we're going to detect using this ML model that we created. So these are all the services that we have to add. And that's it. We're done adding our services. Let me go to the other video. And then we have to create a detection camera. Detection camera uses the built-in camera to transform the image to do something. Currently, our source is the camera. It is going to detect the people, and then the type of detections it's going to do is going to be detections. You can do classification, you can do some other stuff with VM, and the confidence threshold is how confident you want the detection to be. Over here, it says my people detector. We named it just detect, so I'm going to fix that in a second. And then as you can see, the source is the actual camera. So it is using the camera that's on the robot right now through the webcam. And this is going to depend on local, and then we can save our configuration. And that's it. So now we go to the control panel, the same way we tested the components. Now you can see the detection camera, and I'm going to pick the camera up very soon in the video. And then you'll be able to see that it says person, and it has a 80 to 90%. I can go back over there, like 70, 80%. like confidence that it is a person, which is great. Like, as you can see, this took like 15 minutes in total from the part where I got connected to my robot to all the tests. This is a video. It is not directly related with Tipsy right now because we are not using it. But if you want to train your own model, you can basically take a bunch of photos using the camera that you have on the robot, and you can tag them different things. Like in this video, I'm tagging them purple ghost and cyan ghost. And then you can code to say, if you're seeing a pink ghost, then go towards that person. If you're seeing a cyan ghost, then like stay away from that person and back off, go backwards. So like, this is just an example on like how you would train your own model. But again, like you can train it on your face. So maybe it only comes to like the mom and dad to give the beer and like not the kids. So like you can do different variations of the training. And the last thing we have to do is to code. I don't have a video for this in this step, but you just go to the code sample, and on top you can see all the languages that we currently support. The code dynamically gets generated for all of those examples. I feel most comfortable with Python, so in this project I use Python. They all have the first step, which is installing the Viam SDK for that language. And as you can see in the following code, everything that you're going to need to use in that code is already dynamically imported for you. Every time you add a new component or delete a component and you save your configuration, this code sample gets updated. So you don't have to worry about, oh, I created a board and I don't know how to code to use that board. You basically include your secret. Let me go back and show where it is. You include your secret, which is going to be the secret that allows you to connect to your specific robot. Each of the robots have a separate secret, obviously for security reasons. If you include that in your code, which I'm going to show right now, this is how it looks like. I copied the example code and then I added some stuff, which I'm going to run you through right now. If you add your robot secret here and robot address on top, then you will be able to connect to your robot. In base name, I'm saying Tipsy base. If you name your base a different thing, you can change it over there. Same with the camera. I named it cam, so it just says cam. And for ultrasonics, I have 2 ultrasonics in this project. If I had more, I could have added more ultrasonics and split them. The first function that we are going to use is the connect function. As you can see, it uses the location secret and location, like secret and location for the robot and the credentials that you specifically have for that robot, and connects to that robot. The second function is defining an obstacle detector. It is going to get a reading that's going to be the distance reading, and the one below that is gathering all the obstacle readings. Because I have multiple sensors, I'm getting readings from all of them. So you can list the sensors, but depends on how many sensors you have on the global sensor variable, this will differ. The function that says obstacle detect loop, it's basically running a forever loop detecting if my robot is close to an obstacle. It is saying if any of the ultrasonic sensors are close to the object that it's seeing, less than 0.4 meters, then it is going to stop the base if it's moving straight. And then I have very similar person detector. In the person detect, I'm using another forever loop, and I'm basically saying start detecting if your confidence is over 0.7, which is around 70%. And if the thing that you're detecting is a person, then you just say found true. This is very important because you saw all of those things in the label text file. If you change this to if the class name equals elephant, then it is only going to work when it sees an elephant. So you can easily change what type of object shape person that you're looking for. After that, we have the if found function. Over here, you see if all of the distances are bigger than 4 meters, then it is going to continue moving straight. And if else, like if it didn't find a person, then it is going to turn 45 degrees and it is going to continue looking for a person. And then this again loops forever. And then the last function we have is our main function. It's initializing the base, the sensors, and then the detector. Over here, I have to change my detector name to detect. And then I have two asynchronous loops that are running at the same time. One of them is the obstacle task, which is looking at the obstacles. And then the other one is a person task, which is looking for the people and then moving towards them. And that's it. So under it's like 104 lines of code. You can control your robot. And in the next slide, this is how it looks like on your terminal. I'm going to do a live demo so you will be able to see it. But it basically says will detect, it looks around. If it sees a person, it comes towards them. If it sees an obstacle, it stops and then it moves again to find a person. Cool. So meet Tipsy, but in real life. So I'm going to stop sharing my screen so that you can actually see. This is how it looks like. I took the sides off right now so that you can see the inside and everything. And then I'm going to share my terminal so that we can run the code together and then you will be able to see it moving. So share screen, terminal. So I'm SSH into my Pi, and then this is where I'm going to run it. My script is on my desktop for ease. I named it Tipsy Hazal.py. And then if I run in, you will be able to see it coming to me. And then if it like doesn't see me, if I move it away, then you will be able to see it turning. And then when it starts seeing me, it's going to come.
That's awesome.
So thank you. That was it. Now we can, I guess, do a Q&A if you have any questions. I saw that there are 3 things in the chat that I didn't have time to check. I'm not sure if there are questions, but I can answer anything.
So Hazel, while you're running this on the Raspberry Pi, is it still connected to the Viam network?
So basically, the Raspberry Pi itself is connected to the Wi-Fi of the office, but because I have the server on the VM server, like the VM server on the Raspberry Pi, everything is running on the robot. So if I go home and this robot is still in the office and it's on, I can control this robot from my house.
Okay, so the VMware was used to create the software, if I get it right.
So VM itself is the software that I'm using. So VM is like similar to ROS. The way that I'm controlling the robot is within the VM app. I have an account, I have an organization.
Well, okay, hang on, bear with me.
Yeah.
I see you log into VM and play 20 questions with, you know, I've got this wheel, this diameter, that diameter, this ultrasonic, that ultrasonic. And then you said, you know, create, and it created some code, right?
Mm-hmm.
Which you eventually downloaded onto your Raspberry Pi.
Mm-hmm.
Okay, and you're running that code currently at the local with the local Wi-Fi with your workstation and so forth. And that's no longer connected to VM. VM's done its thing, creating the code. Am I saying that right?
Yeah, but in the code, I can share my screen with you. In the code, I'm sharing the secret, but it's okay because I'm going to delete this robot after the presentation, but normally you shouldn't share your secret. Here, you're still using your VM secret. So here you're connecting to VM through the cloud. So yes, we don't have to install the server again. We don't have to do anything per se.
There's a key.
Yeah, but there's a key to your robot secret and to your address. And then if you see these lines, if I go back to my actual screen in Tipsy, let me stop the presentation. Wait a second. Oh, wow. Wait, let me stop. The Zoom is going in front of it. If we stop. All right. So share my screen. Over here in the code, if I include the secret, this is where my secret lives and this is where my location lives. So it's basically still using VM to connect to the robot. I just turned it off, so it says last online 2 minutes ago.
So, VM, is it a subscription service or how does it work?
You can create an account for free, so individual usage and just like DIY. If you want to build 1 robot, 3 robots, 5 robots, it's free. But then the cloud usage, if you have a production robot and you're using a lot of data and you're taking a lot of photos and saving it in the cloud, then you start paying a very minor amount.
So there's no option to use it without using your cloud. Is it an option to use it without using your cloud?
Yeah, you don't have to use the cloud. You can also save your data on the robot. I guess like the reason why you would want to use the cloud if you want to do data management over there and train a model using maybe 300 photos.
So if the Wi-Fi was off, the robot would still run?
I don't think so. And I have my manager over here, Matt, responding in the chat.
Oh, okay.
Hi, Matt.
Hey, Hazal. Yeah, I don't mean to butt in. Actually, yes, client code that is running on the robot can actually control the machine completely without connecting to the app in the cloud. So it's really your choice. Like you can connect securely through grpc over webRTC. That is supported. But if you want, to configure with the app and then take it offline and run your machines completely offline, that is an option. It works, just as well.
Okay, thanks.
Great, thank you.
I saw that someone said in the chat that they chatted with VM at Roscon. That's great.
I was there. I might have spoken to you.
Are these robots for sale?
If you would want me to make you one, I will totally make you one if you want to buy one.
But you are not offering for sale, generally speaking.
I put a link in there for Scuttle. The parts come from Scuttle.
So the base is, I can show you.
What does it cost in parts?
So this base itself, I'm using Scuttle, but you can also just buy your own rails and make your own. There's a Raspberry Pi over there, motor driver. I'm using
What's the diameter of those wheels, Hazel?
I believe it's 250 millimeters. It's like the circumference, sorry, not the diameter. But again, like it doesn't have to be this specific motor and this specific base. You can also just buy one-off materials off Amazon or Adafruit and make your own base. I think I have like another example that I can show. Obviously, this will not carry anything, but like I have another base that I made.
An LM294.
Yeah, it's just like very cheap wheels and a motor driver, and then it has a battery pack in the back and then a Raspberry Pi. So the same concept would apply here. Obviously, it wouldn't be able to carry a big box, but you definitely don't need Scuttle. You can just use any of the materials that you have in-house. At VM, actually, we had projects that people did using electronic skateboards that they found, and like they just took the motors out and used that, or just like an outdoor rover. If you have, you can do something similar, and then you can have an outdoor drinking robot if you drink outside. I guess in New York that's not that common, but in Turkey everybody has gardens. So
a lot of us use ROS here. And I'm always looking for alternatives, some other, framework besides. And I'm looking at VM, and it looks like the big thing is to go there and put in your parameters, and it's creating this code that you can then use. Am I reading that right?
Yeah. And I think one other thing that I personally very much like about VM is that, say, so you have a camera and you added it, it's a webcam, you saved your configuration and you're using it. In 20 days, you change your mind and you want to use a different model of the camera. You don't have to redo your entire wiring diagram and configuration and everything. Like, you can just take your camera out, delete that component, add your new component, save it, and again, your robot works. So if you decide to change your Raspberry Pi to a BeagleBone, if you decide to change your motors to a different make and model of motor, then you can just add that in the configuration in minutes, as you saw, and you can save it and you can test it and you can use code to control it. I saw someone asked, how about a two-wheeled balance board? Actually, one of our community members created a two-wheeled balance board. I can share it if I can find it. I never did a balance board yet, but I will love to work on it. Two-wheeled balance board. It's also on a SCUTTLE. Cool, I found it.
So it helps you go fast, is what I'm hearing, for development. Instead of writing, if you write, we're all used to writing our own Arduino code for microcontrollers, and then Python for high level control, and and there's no framework or anything. It's all or might be some proprietary, some kind of framework, or ROS, I guess, but it seems like, would you say this gets you up and running faster than doing it the kind of more manual way?
Yeah, we don't use ROS actually. Everything is in VM. All of the SDKs that we created, it's written by our engineers and teammates, and you can use those SDKs to they're basically a place that allows you to start your code. It just initializes all of your components, and that's it. Like, it just prints out the resources. It doesn't really do anything with those components. And then you can use any of those languages to add the control logic of what you want to do with that specific component. You can per se, like, I want to use a camera to take screenshots every 3 seconds. And then you can write that in Python. Or like, I want to move my motor for 20 seconds and pump water. You can write that in the Python SDK. So it is extremely fast in comparison to other softwares that does robotics related stuff.
I see where SCUTTLE, they've got some ROS connections, but the pitch seems to be, this is the best place to start. It's Python and Java. And then, you get into ROS later, because ROS doesn't have a learning curve. It has a learning cliff.
Yeah.
Right. So this seems like a good way to, you write your DrinkBot code, whatever, and then you could apply that to another complete robot by just making a new configuration, and the same code will run.
Yeah, exactly. And I actually didn't show you this part, but I can show you right now. It wasn't related with the Tipsy, but it is related with what you said right now. We have a section in the configuration that you can add a fragment. So if, for example, you're using a SCUTTLE and someone already created a configuration and you follow the wiring diagram exactly the same way that they wired their robot, you can basically create a fragment that's a copy-pastable part of your code. If you have a fragment, you can have a fleet of robots in the same wiring diagram, and then you can control them all separately using VM. We have a VM rover, for example. If you add that to your, I'm going to add it just to show you.
I put a link to the VM rover in the chat. It's $100, I believe.
Yeah. So we already had our above configuration that we created together. But over here, as you can see, VM Rover 2022, it's a fragment. It basically allows you to easily configure the same robot in different, in same robot configuration in different robots. So you don't even have to copy paste your code. You can literally create a fragment and just add that into similar robots. So if I did like a production scale Tipsy 20 robots together work in a bar or a restaurant, I don't even have to configure them one by one. I can just create a Tipsy fragment and then add that to all the other robots and control them from VM.
What happens when the network goes down?
I would say for the data stuff, if you're taking photos, it just doesn't sync to the cloud, and then when the network is back, it just starts syncing again and taking photos again. Robot connection, like the motors and stuff, I would just assume that your robot would stop.
Thank you.
Looks great for rapid prototyping. That's true.
Thank you, Niko.
What if one got everything working on your system and then he wanted to run it all locally? Would that be possible with the setup now, or is it all in the cloud and that's the way it is?
No, you can totally run it on your, so the code itself, you can run it on your computer or on Raspberry Pi. Same way the VM server, you can run it on the Raspberry Pi or on your computer. It doesn't have to be in the cloud at all.
Oh, I think you.
One example that I use VM server on my Mac is that I wanted to use my webcam on the laptop, so I didn't want to use a Raspberry Pi and an external USB camera. I just wanted to use my laptop and then my webcam to if my camera sees me, it was gonna turn up my light, this light. So I just downloaded the VM server to my laptop and then I just ran the code on my laptop and that's it.
So you're saying there's a server running on your laptop. That's not, yeah, that's a local cloud local. It's not a, we call it, right. So it's self-contained in your own equipment, basically.
Yeah.
So yeah, go ahead.
And it can be self-contained on the Raspberry Pi or any other board that you're using.
But I mean, yeah, if you write a program on your robot and it's, you've written an autonomous thing, then if the internet goes down, it's going to keep running, right? I mean, it sounds like the code will keep running and all the sensors will keep functioning. It doesn't need the Wi-Fi. It doesn't need any connection.
You're not going to see it on your workstation and stuff, though.
Yeah, you won't connect it to your workstation, but if the robot's already programmed to do autonomous things, it'll keep doing them, right? I mean, like for instance, the drink serving robot, if you didn't have Wi-Fi, why would that stop? It could keep going, right?
I think in the connect function, it is still going to try to connect to that robot, and then if that robot is not live, it wouldn't be able to, unless yeah, I would say maybe there are cases if it's running on your local computer and then all of the other stuff is running on the Raspberry Pi and you're controlling from your house and then only the Wi-Fi in your house is down, or only the Wi-Fi in the office is down, then maybe there would be some cases where the robot would be still running. But
yeah,
I
just mean if you code it in such a way that there's no need for any, communication, it's simply the robot sees a human, the code is all running on the Raspberry Pi. Can you do that? I mean, you're saying it's self-contained, so you have code, the code you just showed us, if all that's just running on the Raspberry Pi and Python, then there's no need to connect anywhere, right?
Yeah, I mean, after the first, when I run the code itself, if I had Wi-Fi, then yes. So if it already connected to my robot and everything is going fine, then yeah.
Yeah, it's already downloaded. It's already started, basically.
Did I see that you have mapping and navigation packages also?
Yeah. We have navigation, we have SLAM, we have vision service, we have machine learning, we have, I think, sensor. Let me see. I can also share them in the chat. We have a specific section that describes all of the services. So we have data management, motion, frame system, base remote control, ML model, navigation, SLAM, sensors, and vision.
And it's the same kind of thing when you want to use one of these modules. It comes up with a template and plays 20 questions.
Yeah,
And
exactly.
then you compile that and you use that code.
Exactly. So if you add SLAM to your robot, it's going to give you an option like, do you want to create a map? And then you can say yes. And if it says yes, you can move your robot around the office and like draw the map of the office. And then you can localize the robot in that map. If you want to use that map again in a different project, you can do that. If you want to see the obstacles using a...
In ROS, we use RViz, ROS Visualizer, you know, where you have the map on the screen then, and you click somewhere on that map and the robot autonomously navigates there. Does the VM software do the same thing?
Yeah, you can localize in the map and go to that location in the map. That's one of the next steps that I want to add to Tipsy, is like having a place where it's oh wow, there's some Turkish people in the chat. Thank you for joining. I'm also from Turkey, that's why they probably just saw the name. I want to have a fridge area, I want to have a bar area, and then I want to have a party area, and I want to add like weight sensors under the like box that it's holding the beers, and I want to say if the weight is and this, then go to the fridge and let someone refill the beers and then go back to the bar area using SLAM, which would be very cool.
You might have to go into production on that after all.
Yeah, I would love that. I guess that's all with the questions. I'm not sure if the presentation was the last in camp or you have an agenda for...
We'll do our show and tell after this. Are there any other questions out there for Hazel?
Yeah, I have one. I just put in the chat. Is what about servos, and particularly an armed robot using tools or graspers or other things on the end of the arm? There are provisions for that.
Yeah, we have. I can actually show you. It doesn't use a servo motor, but it uses a huge arm. We build a claw machine using VM. It's actually in our, like in front of our office, and it has an arm and it has a gripper. So gripper is one of the built-in models that, like component models that we have. It doesn't even have to be a robotic gripper or like pincher. It can be like anything that does the gripping motion. So we used an actual arcade gripper, like arcade claw. Let me run.
Is this VM's office?
Yeah, I'm in the office. So it's...
Yeah, I can't answer this one.
It's right here. It's a little dark over here, but...
Oh, that's awesome.
I don't know if you see inside. It has VM balls that you can grip. And then we created a TypeScript app that allows you to like click somewhere. Oh, for some reason it doesn't go there. And then as you can see, the arm started moving.
It's a universal arm, isn't it?
Yeah.
Okay, what kind of motors are...
It's a X-Arm 6. And then if I press the button, it goes down and then it actually tries to grab a ball. Did I get it? No, I didn't. It's okay. And it comes back to the home area, which there's like a drop hole in the middle.
Is it looking for a particular color or just any of them?
No, currently it's any of them. We want to add like a scoring system that can track if it is picking a certain color, because as we build this, this was for ICRA, we wanted to give away some rovers, and all the colorful ones are the rovers, and then all the black ones are just notebooks and bags and t-shirts, like this t-shirt. So yeah, that's why we use two different colors.
So what kind of motors does that use?
It doesn't have motors. It just has an ARM, Raspberry Pi, and the gripper.
You're talking about that universal arm robot?
But that arm, it has to have
That's-
something to
Yeah, that's
drive it around.
That's a commercial
Yeah.
manufacturing robot arm from
Yeah,
Universal.
It's called X-Arm 6. And it comes with its own software. So like it has 6 different joints that you can individually control.
Okay.
Important to note is that, yeah, the VM motion planning service allows you to actually bring your own arm. Like, let's pretend you did create an arm with, 3D printing and servos. You can actually then define its kinematics with a URDF file. And then the motion planning service can do, essentially the same thing for any arm that you just saw with
That's
the
a
plugin.
$3,000 arm.
Yeah, but you can build an arm, for us, with our kind of things that we tend to do, just using hobby servos. So the Vim software would allow you to communicate with those.
Yeah, and I think we have a tutorial actually on how to create your own arm definition if you were building your own arm.
Okay.
Yeah, I can find that and share it.
Okay. Or we also use servos that don't have locks on them, so they just spin.
360 degree
Yeah.
servos.
So I had a
Hazal, we have another question from
Yeah.
here in the room.
Yeah.
When you're
so, yeah. So I'm one of the original ROS people, and I've seen tons of people try to replace ROS. Okay, everyone's like, we're gonna replace ROS. And nobody's ever been able to do it. Even like Google and NVIDIA have given up. Because the ROS community is just so huge and there's so much energy. It's just like trying to replace Linux at this point. So, and everyone who's tried to do it has gotten into trouble when they've run out of resources and have had to replace everything with ROS again. So my question is, how do we know VM is gonna be able to keep providing? And if VM does run out of resources, is there a plan to transition to something like the Open Source Robotics Foundation that took over from Willy Garage? So that people don't get rugged when the thing goes south.
So I think the difference is that we're not actually trying to replace ROS. It's just an additional software that you can use. I can share our blog. We actually can work with ROS together. So if you say you don't want to build your entire robot in VM, or you already have a robot that's running ROS and you just want to use the cloud service of VM, you can do that. Or you just want to use the ML model, like train your model at VM and then do everything else on ROS, you can still do that. So we are not really trying to replace, we are just trying to add more capabilities to the robotic space.
I don't think you can replace ROS. And the reason is I can go to my customer and I have restriction, EU restrictions, and I cannot use your servers. So I can use you for demonstration, but with ROS, I can have it and the customer can have it there and I don't have to use your servers. You understand the difference?
What type of restrictions?
Yeah, I have companies and they want everything to be in EU. So I cannot use your services.
Why not?
My customers.
Yeah, I used VM. Like I have family in Turkey and they use VM in Turkey and it works. I don't think that it's US specific.
No, it works. I'm not saying it's not working. It's the data protection that some companies put very strict rules.
Yeah.
Not in EU.
I believe our engineering team is working on different support for different regions in Google Cloud that may not cover every single like country by country restriction in the EU, but today we are hosted just in the US, but soon would be offering your choice in terms of any cloud services would happen in the Google Cloud region of your choice.
Then we have to see it again because I had a customer a few months ago and he just wanted local, nothing on cloud, everything local. So this is one of the restrictions. I can make a demo with you, as I say, rapid prototyping. I can make a demo of something. But this
Yeah, if you send me an example, and like if I shared my email, but my email is just hazal@vm.com, my name @vm, we can also work together to see if it works in the specific context that you're asking about.
We'll see.
Because they can also use VM without using anything data management related. Like you don't have to use the cloud. You can just use VM for other stuff too.
We'll see. I'll check. As I say, it's good. Looks great for approval. If I can, with Ross, I'm struggling. It's my fault. But
Yeah,
with,
so if you want
no,
to try VM, let me know if you have any questions and I will help you out.
I will do. Thank you.
All right. Can you hear me?
Yeah.
Okay. My phone died a little earlier. So we had that last month also, but regardless. Okay. So are there any other show and tells this evening? I was just showing my bot vac running around and making awesome in Tallahassee today. We've got a homebrew robotics club in Tallahassee also. Any other show and tells this evening? I see Thomas. Thomas, go ahead.
Hey there. A long time ago, I used to work for a company called Androbot. It was formed by Nolan Bushnell, the founder of Chuck E. Cheese, as well as Atari and probably a dozen other companies. We were building these. This is called Topo. And Topo is an antique robot. He's from the 1980s, early 1980s. And he was run by... What's that?
Yeah, I just wanted to say if we're done with the VM's excellent presentation.
Yes, excellent presentation.
New York,
Thank you.
live from New York. It's nearly midnight over there, and they stayed to share their time and their expertise with us, and we really appreciate it. Thank you. That's all. And
Yeah.
carry on, Thomas.
All right, back to Topo. So I was a junior engineer over there, and there was probably a dozen employees at the time. This was the first commercially built robot that was sold to the general public. These things back in 1984 were running about $1,500 to $2,500, depends on which model you got. This is the first, one of the first models, the lower end. It has no sensors. It was run from an Atari or a Apple computer. But I've got it on remote control for now, since I just got it running about a week or so ago, and I just wanted to show it off. There's whole groups of people out there who are building these things with 3D parts. This one was cast in plastic. What's really nice about those wheels is the way they're canted at a 15-degree angle, I'm guessing. If it bumps into things, it goes around them rather than getting stuck. It's interesting. And the engineer who designed those wheels said those wheels want to stand up straight. They tend to want to go right up straight and be a self-balancing robot, but that never happened.
I'd always wondered about that wheel design. It's pretty cool.
Yeah, that's all I got to show, guys.
Thank you very much, Thomas. Any other show and tell this evening?
Thomas, was there a third caster back there? Is there a third wheel on that, Thomas?
Thomas, is there a third wheel?
There's a caster front and rear. There's one right under his belly in the front and right under his butt in the back. Right about here. Any other questions?
So I've got some of my Halloween. My phone's died, but
Oh,
I'm
yeah.
out here with some of my Halloween robots. There's Sammy. Say hey, Sammy. And then everybody knows Rocky. I had Rocky out at the oh, how are you doing? Had Rocky out at the Making Awesome this afternoon. Any other show and tell this evening? All righty. Well, we had some fun. We had a great presentation. Thank you very much. Hazel with
Camp, I
Viam.
can Camp, I have
Viam,
a short video.
Go ahead, Jim.
I have a short video of Orange, a little update on getting retrieving a bottle. It's moving forward a little bit. First time it actually worked. I'm gonna show my screen here.
Is this a Floorbot challenge phase 2?
Yeah, phase 3 now, right? To
Are
retrieve.
you fetching the object?
Right.
Oh, be still.
Hey, Orange, retrieve the bottle. Okay, I'll search for a bottle. Okay, I see a bottle. I found the bottle. Now I'll retrieve it. It's too close.
Yeah, so this is like an effort to use multiple cameras and then a sonar.
I have the bottle. I'll bring it back.
The first time it succeeded.
I'm going to the origin.
I still have some work to do. For instance, the sonar is blocking. The sonar is used for obstacle avoidance, and the bottle is now in front of the obstacle avoidance.
Looks like it's done some adaptation there.
Yeah, well, the problem is that, like I said, I was using the SlamTech system sonar connection basically that's used for obstacle avoidance, and I'm picking up a bottle right in front of the sonar, and so then it's trying to go around itself, around the thing that it's holding on to. So I'm just gonna, that was like
So it looks like you found the object, but you didn't bring it back.
Yeah,
correct?
so I haven't
Okay.
qualified for number 3 yet.
That sounds good.
It's
It looked like
getting
it was
close.
trying to move the bottle down so it could get back to the destination.
Yeah, like I said, the problem is it's like a stupid thing. It's trying to, it's blocking its own sensor for obstacle avoidance. So I'm gonna not do that anymore. I'm gonna plug it into the
Future's going to be weird.
yeah. It's just
You're going to pick up a hockey puck instead.
pick up a hockey puck.
Thank you, Jim. Okay.
Yeah, I think.
Any other show and tell for this evening? Want to thank everybody for coming out. We had a fun. Special thanks to Viam and Hazel for that awesome presentation.
Nice meeting y'all. This was great.
We meet the last Wednesday every month, so join us. All right. What are you saying, Mike?
I'm giving away a Niko vacuum system here.
Oh, Niko vacuum system. Okay, we got some bot vac action going on. So get the bot vac and show up at our Ross discussion group. We'll get it mapping and navigating. All righty. Thank you very much. Thank everybody for coming out, and we'll see you again next month. See you at the business meeting on November 1st. Meeting closed.
Bye-bye.
Thank you, Hazel. Thomas, you can stop the recording. Good to see you, Dillo. Good to see you, Steve. Good to see you, George. Chris?
Camp and Thomas, try to save the chat, okay?
Yes, save the chat.